right, so today we're going to look at Chapter 7, Administrating a Secure Network. In here we're going to list and describe the functions of a secure network protocols. We're going to look at the placement of secure devices and technologies. Look at how security data can be analyzed. And finally we're going to explain how to manage secure network platforms. Okay, when we're talking about networking and secure network, we need to look at network protocols. Protocols are the rules for communications. These are something that they're essential for having the different devices on a network talk to each other so they can communicate. What we're going to talk about is the transmission control protocol / internet protocol. It's commonly going to be referred to as the TCP/IP. This is going to be your most common protocol suite that's going to be used for local area networks and the internet. And it's got several protocols that are all going to function together. So when we look at this, we got the IP protocol. Now, last week we talked about the OSI model. So this one is going to be something that operates at the at the network layer of the OSI model. And it provides the network addressing and routing. So it's basically telling the messages, this is where you're going, or the data, this is where you're going, the packets. The TCP works the transport layer, and it's used for communication. So it makes the communications, it ensures that the data transport between the devices are reliable, and it uses a 4-layer architecture for the TCP/IP. Network, interface, internet, transport, and application. So when we talked about the OSI model, we had 7 layers. So the TCP/IP only uses 4. So we can see here on the OSI model, the application, presentation, and sessions layers. That's going to be handled by the application layer on the TCP. Transport is going to be transport on both of them. Network is going to be named Internet on the TCP/IP, and where the data link and the physical layers are going to be linked into the network interface. Now we have several different TCP/IP protocols that are going to be used related to security. You have your simple network management protocol, your domain name systems, and your file transfer protocol. We also have email protocols. They're not going to be necessarily natively secure. So you need to take other steps to make sure that your email correspondence are protected. So we'll start looking at these protocols. We'll look at the simple network management protocol first. It's used to manage network equipment. It's supported by most network equipment manufacturers. Now what this does, it allows the administrators to go in and to remotely monitor the network. They can also look at it and manage, configure the devices on the network. It functions by exchanging management information between network devices. And what this does, the SNMP managed devices, they have an agent or a service. They sit there and it listens for and executes any type of command. Now these agents are going to be password protected. The password is known as a community string. It did have security vulnerabilities in versions 1 and 2. Version 3 was kind of used to address these. It uses username and passwords along with encryption to address those vulnerabilities. The DNS, the domain name system, this is a TCP/IP model or protocol that maps IP addresses to their symbolic names. This database is going to be organized in a hierarchy, so it's going to consist of a site name and the corresponding IP number. What this has done then is it is going to be distributed. This database is distributed many different servers over the internet to stop bottlenecking, stop it from being bogged down so much. So when we look at an example of this, so look at step one here. So this guy here needs the IP address of www.nashville.com. So this is what he types in. So then it's sent to the local DNS server, who is then going to send out and say, okay, well, what's the address of the .com server? Where are all the .com websites stored at? So in there, it's given the .com server's IP address, because that's going to be sent back to the DNS. And then it's going to say, okay, we're going to now look. We know where the .coms are. So where is the Nashville.com? So it goes out and gets the Nashville IP address. And that is sent back. And then finally, it's going to look for the address of the www.nashville.com. And it finally gets the address of 158.24.3.9. Okay, and that is what's being sent back to the user. So when you go in, you type in, say, google.com. Same process happens. You go to your local DNS server. This is where's the .com servers? It goes and finds that information. In this case, it's 10.35.83.77. So then it goes and looks for that IP address. With this situation, would find google.com and come up and then look for www.google.com. And you can see here we got the different IP addresses listed here for Memphis, Nashville, Knoxville. So if this would happen to send out one of these other IP addresses to this, something's going on. There's some kind of attack happening with the DNS server, possibly. So DNS spoofing, we're sending out a different IP address through this. So we got DNS. Like I was just saying, it's often the focus of the attacks. DNS poisoning substitutes a fraudulent IP address. So it takes, this is something to be done either in the local host table or the external DNS server. And what it does, it takes the IP addresses and sends the wrong IP address. It sends the wrong information back, changes the resolution, the name. So you could use the domain name system security extensions to help protect about this, and this adds additional resource records and message header information that can be used to verify requested data, and it's not been altered in the transmission. Now, when an attacker asks the valid DNS for a zone transfer, what that does is that zone transfer allows the attacker to access network, hardware, and operating system information. The file transfer protocol, this is used for transferring files. It is an unsecure protocol used to connect to an FTP server. Now, there's a couple of different ways you can use FTP on a local computer. You can use it from a command prompt, a web browser, or you can use some software, an FTP client. So we'll see an example here of a client where they get their information here, the status, the response. So this would be like the file you're choosing to upload, and then where you're sending it to. Now, if you're using an FTP behind a firewall, you can have some problems with this. FTP uses two ports. Port 21 is the FTP control port, and port 20 is the data port. So if those ports are closed or your firewall or restricted, you may not be able to send files through that. The FTP active mode, the client's firewall may sometimes drop packets on port 20. And if it's in passive mode, It's going to send a PASV command to the command channel. Servers will respond with a TCP port number to be used to establish the data channel. Some vulnerabilities at FTP is it does not use encryption, and they're also vulnerable to man-in-the-middle attacks. Now, you do have some secure transmission options with file transfers. You can use the secure sockets layer encrypt commands. So this uses the SSL or TLS. It encrypts the commands sent over the control port. Data port may not be encrypted. You can also use the secure FTP. This is going to use a single TCP port instead of two, and all data and commands are encrypted using this. We also have some secure email protocols. Secure multi-purpose internet mail extension. It's a protocol for securing email messages. There are some limitations with this. It cannot be used while the email is being accessed through a web browser. And also because it encrypts the entire message, it's going to make it difficult for any third-party tools that inspects email for malware. Another reason why is because that malware will be encrypted as well. So we're looking here at some applications and technologies and then the recommended secure protocols for these. The one you're probably most familiar with now is the web browsing using the HTTPS. Remote access, you would use a VPN, which if you remember, that's going to take two endpoints. It's going to send encrypted data over a unencrypted and open network. We also have to take into consideration the placement of security devices and technologies. So if they're not in the proper location on the network, they can be less efficient or really do nothing at all. We look at a SSL TLS accelerator. It's a separate hardware card that inserts into a web server. It's going to contain co-processors that handle the SSL TLS processing. Now this is also, this module can also be installed as a virtual server. Port mirrors, they allow the administrator to configure a switch, copy traffic that occurs on some or all the ports to a designated port on the switch. Network tap is also called a test access point. What that is, it's a device that allows you to monitor the traffic on the network. So we're looking here on this example of port mirroring. We have the internet. We have a network switch with a mirror port, and we have a network analyzer. So the traffic's going to come through here, and it's going to be mirrored to this device. Network tap, same thing, comes through. The internet traffic comes through. The network switch is going to hit the network tap, which allows it to be sent to the network analyzer. You can also have sensors, collectors, and filters. These should be placed where the stream of data is the largest. So sensors are going to monitor traffic for network intrusion detection and prevention devices. Collectors are going to gather traffic for the SIEM devices. Filters are going to block traffic for internet content filters. The aggregation switch used to combine multiple network connections into a single link. This should be located between the routers and the servers, so they can detect and stop attacks directed at a server or an application. Correlation engine, it aggregates and correlates content from different sources to undercover attack. This is something that should be placed in the protected internal network. It uses data collected from the logs of different hardware devices. A DDoS mitigator, it's a hardware device that identifies and blocks real-time distributed denial of service attacks. Once again, this should be somewhere that can monitor the largest stream of data. Security data needs to be analyzed. We got a couple ways we could do this. We've got security logs. Security logs, they reveal what types of attacks are being directed at the network and also if the attacks were successful. We also have access logs. They provide details regarding requests for specific files. Audit logs are used to record which user performed an action. And event logs, they document any unsuccessful events and the most significant successful events. Now, a routine review of logs, they help us identify things such as security incidents, policy violations, fraudulent activities, or operational problems. We see here that it also says that logs can be useful for performing auditing analysis, supporting the organization's internal investigation, and identifying operational trends and long-term problems. They're also there to help an organization if they need to prove that they are obeying federal regulations or any type of laws. It's like backing up the evidence. You know, if the federal government come in and wants to see, let's say we're working in the banking industry, and they want to make sure that we are following their banking protocols. We have the logs that are backing that up, and it can be used as proof. So to get the data from security devices, pretty much everything is going to have a way to generate a log. Every type of security device or device that's designed for security, firewalls, for example, you can look at those to determine what IP addresses were rejected or dropped, what probes to ports that help no application services running on them, source routed packets, suspicious outbound connections, and unsuccessful logins. You can also get data from security software. For example, the data execution prevention. It's a Microsoft Windows feature that prevents attackers from using buffer overflows to execute malware. These events and stuff from similar software, they can be logged along with the level of severity. You can have a file integrity check. That's a service that can monitor any changes made to computer files. These are something like the operating system files. Those files, those changes can compromise security, and it can indicate a security breach has occurred. It may be something as simple as there's a file that's turning off the software firewall. We can also get data from security tools. For example, the tool, application whitelisting. The description of this is a whitelist is an inventory of applications and associated components that have been pre-approved and authorized to be active and present on the device. These are designed to permit only known good activities and block everything else. We can also set up a removable media control. So that says what types of removable media can be used on a system, can be attached to it. The reason we may do this is because we want to limit the opportunity for malware to travel in on a flash drive or somebody to steal data and copy files to a flash drive. So we may have this set up. You also have advanced malware management. And this is often a third-party service, and it's a tool that monitors the network for any unusual activity. And basically it's going to use experience-based techniques, and it's going to look and see if there is any type of threat exists. Now we do have issues with log management. Some of these are generating, transmitting, storing, analyzing, and disposing of a computer system's computer security's log data. Problem we have with this is that multiple devices generate logs. There is a very large volume of data, and you also have different log formats. Now, the solution to this is usually a centralized device log analyzer. So we're looking at a screenshot here of a centralized device log analyzer. Where over here we can choose the type of firewall. We see our traffic trend reports. This is the hourly trend comparison, weekly, working hour traffic distribution, and non-working hours. And then we have other information here. Now this will not be the only screen you would look at in this, but you could use this to analyze the data. Now some applications or platforms will require a specific or special security considerations. Things such as virtualization, cloud computing, or software-defined networking. Virtualization is a means of managing and presenting computer resources without regard to physical layout or location. We will talk about the host virtualization. It's where an entire operating system or an operating system environment is simulated. Virtual machines are a simulated software-based emulation of a computer. And on this, the host system runs a hypervision that manages the virtual operating system and supports one or more guest systems. Think of this as MonTap. When you guys log into MonTap, you are logging into a machine, but it's a virtual machine. Okay, it's going to reset once you log off. VM monitoring program is called Hypervisor. It manages the virtual machine operating systems. You got two types of this. You got type 1 and type 2. Type 1 runs directly on computer hardware instead of the underlying operating system, while type 2 runs on the host OS, kind of like an application. We also look at containers or application cells, which those will hold only the necessary operating system components that are needed for that specific application to run. Now, this does help with reduce the necessary hard drive storage space and RAM needed, and it allows it to start more quickly because you do not have to start up the operating system. All right, VDIs, virtual desktop infrastructure. This is the process of running a user desktop inside a virtual machine that resides on a server. Enables personalized desktops for each user to be available on any computer or device that can access the server, and also allows centralized management of all virtual devices. You will notice on campuses that we are going to more VDIs. Here at the Catoosa campus, other than the 2 CIST labs, every other computer on this campus is run off of VDI. It allows them to remotely, from a central location, manage those. Virtual distributed Ethernet, that's an Ethernet compliant virtual network. It can connect physical computers or machines together. Now, advantages of virtualization. If you expand, it's a lot easier. It's a lot more cost efficient to expand with more hosts. That's called the host elasticity. So if I need to add more computers to the network, it is easy to do. It also reduces costs because I have fewer physical computers that I need to purchase or maintain. And I also can have uninterrupted server access to users. Now, virtualization does also cause some security-related questions and some advantages. One of the advantages that you can test the latest security updates by downloading it on a virtual machine before installing it on production computers. So I've got a virtual machine that's set up, and it's exactly what you're using out on the company floor or using as working for the company. So I can test any type of server or security update on that virtual machine and see how it's going to affect the rest of the production, rather than just pushing it out and hoping for the best. Another thing that I can do is I can have a snapshot of a particular state of a virtual machine, and I have that saved for later use. So let's say I'm testing the security update. I can take a snapshot of the virtual machine, which what that does is that saves it at that point in time of how the operating system, how the machine is working at that point in time. Then let's say I test the update and I find that it breaks 3 of our company programs. We can't use it. We have to use these programs. Okay, rather than go back and load everything, I can just go back to that state and load that last state. I can also test the existing security configuration on a simulated network environment. If I have a suspicious program, I can load those onto the virtual machine and execute it. This is called sandboxing. You guys have probably seen that in the past. You take a program, you load it in the sandbox. Windows, especially Windows XP and Vista, they really wanted to open up and install everything in the sandbox first. And what they wanted to do is they didn't trust the software, so they wanted to test it. Now, the advantage of that is if it is malware, only that virtual machine is going to be affected, not everything else. Now, once again, there is some security concerns for virtualized environments. Not all hypervisors have the necessary security controls to keep out attacks. A lot of the existing security tools were designed for a single physical server. VMs must be protected from both the outside network and other VMs on the same physical computer. They also may be able to escape from their contained environment and directly interact with a host operating system. One of the things also you have to look out for is the virtual machine sprawl, which is widespread proliferation of VMs without proper oversight or management. Basically, nobody's overseeing everything, taking care of it. We also have to talk about cloud computing and a couple of different options we have here. You have the on-premises model. And this is something where it could be very expensive. What happened here was that companies, enterprises would purchase all of the equipment, the hardware and software needed to run the organization, and they would have an on-premise. You can also have hosted services, and this is where it's shared by multiple enterprises over a remote network connection. And the servers, storage, supporting network infrastructure, and such are shared. Cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. It is a pay-per-use computing model where customers only pay for the resources they need. A lot of this you may have seen already with cloud storage is one of the biggest ones right now. So where you, like if you have an Adobe subscription to the Creative Cloud, that's using a cloud service where you're paying a monthly fee to access the software. Cloud computing, same with Adobe, is they include, say, 20 gigs of free storage. So it's a place that you can access, you can save your files, and you can go back and access them from anywhere that you have an internet connection. So we have some types of clouds. We have public cloud, community cloud, private cloud, and hybrid cloud. When we're looking at using the cloud, we touched briefly on this a second ago with the Adobe example. We have 4 service models. You have software as a service. So this is where the vendor is going to provide access to the vendor software applications, and it's going to be running on a cloud infrastructure. Think of this as Adobe, the Adobe Creative Cloud, or Microsoft Office 360. Platform as a service is where customers install and run their own specialized application on the cloud computing network. Infrastructure as a service allows the customers to deploy and run their own software, including operating systems and applications. Now you can also have security as a service, which is where all security services are delivered from the cloud. There are some challenges for cloud computing security. The cloud provider must guarantee means to approve authorized users and deny imposters. The transmissions from the cloud must be protected. Customers' data must be isolated from other customers. And the highest level application availability and security must be maintained. We also have cloud access security brokers. These act as a gatekeeper, and what they are a set of software tools or services. They're going to reside between the enterprise's on-premises infrastructure and a cloud provider's infrastructure. And they ensure that the security policy of the enterprise extends to the data in the cloud. A software-defined network virtualizes parts of the physical network so that it can be more quickly and easily reconfigured. These are accomplished by separating the control plane from the data plane. So we see we have our data plane, we have our packet switch, a router, LAN switch. Our control plane is going to handle the routing, the traffic control. So with a SDN All right, so if traffic needs to flow through this network, it's going to receive permission from the SDN controller. It's going to verify that the communication is permitted by the network policy. Once it is approved, the controller then computes a route for the flow to take. It's also going to add an entry for that flow at each of the switches along the path. Now, these can be used to provide stronger protection because it simplifies existing VLANs between the perimeter, beyond the perimeter of the building, which can help secure data. It also can ensure that all network traffic is routed through a firewall. It can help capture data for NIDS and NIPS. All right, so once again, TCP/IP is the most common protocol for LANs on the internet. We do have some protocols for transferring files. You got FTP and FTPS. Remember, FTP is unsecure. Make sure that you have secure devices positioned in the correct place on your network. You can monitor the traffic through a managed switch or install a network tap. Your log is a record of all events that occur on your network. Security logs are important because they can reveal what types of attacks are being directed at the network. If you're using log management, you want to use a centralized device log analyzer. It's going to centralize all of your logs, make it a lot easier for you to analyze those information. And then be aware of the special security considerations for virtualization, cloud computing, and software-defined networks.